Hi.
Hi.
Okay, I think Perla is coming in a minute.
Okay.
Well, I'm doing the variance, which is the sum of the deviation
Uh-huh.
of the square deviations, and then we that the square root of that sum is a standard deviation, right?
I think so.
So do you have any? Do you have the variance or not?
I don't. I was working on the Google Hangout.
Okay, I was working on it. Just a second.
Is Megan here? Oh, yeah. Sorry, ladies. It took me a while.
It's okay.
Is Megan here? She is, right?
I thought, yeah.
Megan?
Perla,
Yes.
well, I think the variance is 1.534, and the square,
Where are you? 14?
wait, and so the standard deviation should be 1.239. Am I
Did you
okay?
already did that, the math?
Yeah, I'm doing it by hand, the standard deviation.
Let's see.
That's what you got?
No, I didn't do the math.
You do it by,
I was trying to do it with Excel, but now I'm going to try to do it by hand. So you calculated the standard deviation
by hand.
by hand? Okay, 38.1. This is a mess. So you did all the deviation from the mean of each one of them, and then the square deviation? Is that
Yeah,
what you did?
yeah. Then the variance,
Mm-hmm.
and then the standard deviation.
Is Megan here?
She
I
was,
am. I'm looking for my.
Okay, take your time. I was just trying to make sure that I was in the right place with
Oh,
Sylvia.
you're good. I
Okay,
just lost my notebook.
it's okay. We need your
Found it.
notebook.
I do need my notebook. Okay. So is this a standard deviation of the sample means?
Yes. Well, let me see. It's asking us for what is the standard deviation of these temperatures. So we need to calculate, if we haven't, we need to calculate that.
So then it's the mean.
Minus the standard deviation of each, and then the sum of them, right?
Well, in my notes, it just shows the mean divided by the standard deviation over the square root of n.
Oh, so that means 38.075 minus what?
No, it's the
Well, I think it's the square root of the sum of the square deviation.
I don't know what that means. I have no idea.
Oh, hold on a second. I'm trying to find it out. Let me see if my results match Sylvia's. Were we supposed to do this by ourselves first? Is that why it's taking us so long?
No.
No, right? We were supposed to work together on this.
Yeah.
Yeah, that was my understanding. Okay.
Okay, so here's my calculating the standard deviation. Make table to calculate mean of the variable. Add a column whose values are found by subtracting the mean from each of the observations, squaring it, and multiplying it by the probability for that value. Add up the values in this column to get the variance. To get standard deviation, we find the square root of the variance.
Okay.
Yeah.
Do we know the variance?
The variance is 1.534.
So then we square root.
And the square root is 1.239.
So that's a standard deviation.
I think so. I hope.
Well,
Right?
we do get another chance to take the same quiz.
Oh man, I hope we don't have to.
I know what you mean.
This is my second time taking this class, and I'm just about over it.
Oh, you're going to pass this time. Yes, I'm just talking about this quiz right now. Yeah.
And then I said for question number 15, it says under certain conditions, the standard deviation can be negative, and I said false.
Hold on a second. For number 14, what do you have? 1.239?
Yeah.
Yes.
Okay, 1.239. And then you have false on 15, right? Because the standard deviation can be negative on certain.
Yeah. False.
Oh, is it false?
Yeah.
Yeah.
Okay. So we should go to,
The next.
they gave us the standard deviation. Okay. In the same study, the researchers placed thermistors, temperature sensors in the 3 seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. Oh, well, blah, blah. They placed thermistors in 6 other seals named Richard, Jerry, Sammy, Nut, Johnsy, and Butler. In their aorta. Do we need to know all of this? The
No.
largest artery in the body. Finally, they placed thermistors in 4 other seals named but later appeared in the hepatic sinus. The results for this studies are summarized in the table. Okay. Which location result in the most consistent temperature measures from one seal to the other?
It would be the one with the lowest standard deviation, which would be the extradural.
Yeah, I agree.
Okay.
Because the larger the standard deviation, that means the farther away from the mean it
Cover
is.
the mean. So the closest they are to the mean is the one that is more accurate. Is that what you're saying? Okay, so we have B on number 16.
Yeah.
Yes.
And then the number of hours students spent studying an exam were recorded. The data below. Use this box plot to answer the next question.
What is the third quartile?
It is 8, right?
Yes.
Yeah.
What percentage of the data lies between 4 hours and 8 hours? Note, list the number as a percent and not as decimal, and do not include the percent sign. Example, if the answer is 66%, then input only 66, not 0.66. So
I think it's 50%, right? From 4 to 8. That should be 50 because it's the first quartile to the 8 to the third quartile. Am I okay or not?
I think it's right. 6%?
I think it's 50%.
Oh, 50%.
Yes.
It's right in the middle. The 6 is right in the middle. What do you think, Megan?
Well, I don't think it's 50 because if you look at the histogram,
it's 12 all the way up, right?
Yeah.
So
is this that 68, 90, that one rule?
The 68, 95, 97, 99.7 rule.
Yeah. I think it is.
I think it is. So that would be 68%, right? Or not?
So 68% of the observations, 68% of the data will lie within one standard deviation of the mean.
Okay. It seems. I think it's 68. What do you think? Percentage of the data. It is one standard deviation. You're right. So it should be the 68%. Right?
I would say so.
Yeah. Okay.
All we can do is try, I guess.
Yes. An observation from a normally distributed population is considered unusual. It is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 ppm parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nutrient concentration in the city's drinking water supply is between 1.59 and 2.52 parts per million. The values outside of this range are unusual. We will assume mu minus 2 sigma equals 1.59 and mu plus 2 times sigma equals 2.57. It is reasonable to assume the measured nutrient concentration is normally distributed. Estimate the mean of the measured nitrate concentration in the respect drinking water. The mean. Okay, hold on a second. This is the formula. And more than 2 standard deviations.
So can we use that Excel sheet?
I think so, yeah.
So we know the. Do we know the mean? No.
Well, I think we need to use the okay, how do we calculate the C-score? Okay, we have this. We don't have the standard deviation. Is it that simple just to add both of them?
But we don't know the measured nitrate concentration is above.
So
The
we
city
just
reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.52. And values outside of this range are unusual. We will assume mean minus 2 standard deviations equals 1.59 and mean plus 2 sigma equals 2.52 ppm. It is. What does that mean?
I think it's 2.055.
How did you get that though?
You add them and then divide it by 2, because if they're equally separated, one being on the left side and the other one being on the right side, right?
That would make sense.
It's the only thing that occurs to me because I didn't see that. But of course, I haven't seen the video for the test. So I got 2.055 to be the mean. What do you think?
I think that makes sense.
Okay, let's give it a try.
Is there a standard deviation? No, right? No.
No, I don't see a standard deviation. It just says the 10 concentration thing.
Well, it doesn't give us a standard deviation because the next question is estimate the standard deviation in the measured nitrate concentration in Rexburg drinking water.
So
well, it should be 1.02.
1.028.
No. Wait.
One minus. What did you get for number 20?
It's 0.232. 233.
0.233?
Yeah.
Between what two measured nitrate concentrates do approximately 68% of the data lie? So we would add the 0.233 to that 2.055.
Mm-hmm.
And it would be, sorry. So 2.055 plus 0.233 equals 0.228 or 0.288.
So that would be the last one.
Yeah. And then you
B.
take
Uh-huh.
the 2.055 minus 0.233, and that equals 1.823.
So it's D.
Yeah. So we must have done something right. We're getting the answers to the multiple choice one.
We are.
Use the following information to answer the remaining questions. The admissions committee for most Masters of Business Administration program require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What is the probability that a randomly selected student will score above 542.3 on the GMAT? So
Okay.
this is where we need a Z-score, right?
Yeah, we need the C-score first.
So can't we put in mean? This is where we can use that Excel sheet. So we use mean of 542.3, standard deviation of 120.54, and then what would our X be?
Where are you right now?
X, I think, is 542.3. Right.
Hold on a sec. Let me read the question.
I don't know.
Because it's the same of the mean.
But we're trying to find what is the probability that a randomly selected student will score above. So we have to find the Z-score and then put it into the applet. Oh, we could use that applet that he gave us, can't we?
Yes, but the C-score is X minus the standard deviation divided the minus the mean divided the standard deviation. So we have that X is 542.3.
Yeah.
And then our mean.
The mean is the same.
Yeah.
Oh. So we don't use that formula. We use the other one. What is the probability? Yeah, if it's gonna be, it was standard.
I'm gonna try to use that applet that he gave us. See if we can do it that way. Okay, so we have a mean of 5 42.3. And what's the standard deviation?
120.54.
Okay. And we want it above the 542.3. So the probability equals 0.5. Which makes sense because it's the mean.
Yeah, hold on a second.
I don't know how to do this because this, what is the score in question 22 is the same as the mean, so I don't know how
So
to do
if
it.
it's the mean and we want to know how many above it or what the probability of scoring above it is, if it's the mean, it would be half,
Okay.
50%. It seems too simple, but it makes sense.
I got a C-score of 0.479.
How did you get that?
It's the 600, which is the less than, that's the probability. That we use the formula of x minus the mu divided by the standard deviation. So our
So you
x in this case is 600 because it's telling us less than. So the
right. What was
C-score,
the probability you got?
540. The C-score is. Hold on a second. Hold on a second. I need to put that down. How many digits are they asking? How many digits are they asking for? Should I round it up for 3 digits?
3 digits.
Okay, so we're gonna calculate below, and then
I got 0.684.
yeah, that's what I got.
What's the probability?
0.684.
37?
Is that what you got, Megan?
Yes.
0.684.
Yep.
So that's our answer, right?
Yep. And then I did 24. It is, what is the probability that a randomly selected student will score 600 or above the GMAT? And I got 0.316.
Hey, what was your answer for 23?
My answer? Sorry. It
Yeah.
is 0.684.
And for 22?
For
22
22 is, for 22 is 0.684, right?
No, for 23, it's 0.684.
So what do you have for 22?
I have 0.5.
0.684 for 23 and 22?
0.5.
Just 0.5?
Uh-huh.
Thank you, Megan.
Yeah.
Okay, what is the probability that a randomly selected student will score 600 or above of the GMAT?
0.316.
How did you calculate that?
I used that applet he gave us.
Okay. Do you know the answer for 25? I am kind of lost here.
I don't.
let's see, find the GMAT score that corresponds to the 10 percentile. Round
I'm looking at my notes. Hold on. Okay. Find z-score that corresponds to the desired percentile.
So would that be?
Click on the areas under the curve until the area to the left of the positive z-score are all shaded. Oh, hold on.
Are you using the applet, the blue one or the black one that he gave
We're gonna
us?
have to use the blue one now.
Okay, so we shade the ones in the bottom, right? Just the one in the on the left.
Yeah, to the left of the positive z-score. Type
To the
desired
left.
area or the percentile at the top of the graph. So would it, for the 10th,
Mm-hmm.
what would the desired percentile be? 0.1?
I had minus 0.282. Maybe I did something wrong. I think I did something wrong.
Well, no, this is, I don't know.
Hold on. We can do this. We can do it. Find the GMAT score to the nearest whole number.
We just have to know what,
Uh-huh.
I just don't know what the area for the 10th percentile is.
How did we find the area of the 10 percentile?
I don't know.
Oh, it should be 0.1.
That's what I thought.
I got the same, 0.1.
Okay. So type the desired area or percentile at the top of the graph. The z-score corresponding to this area will be displayed in the bottom right box. So it's 1.282.
Yes, that's what I have.
Okay, find average corresponding to z-score of percentile by solving for x. But I don't know what we're solving for x in.
Okay, so we have z-score x minus mu divided the standard deviation.
Oh, I see what you're doing.
So now we have the z-score times the sigma plus mu, that would be x, right? If you
Hold
give
on.
me, okay.
What's the z-score? Z equals,
See, okay, it's
I got it.
1.282, right?
No, never mind.
I'm not helping, right?
No, you are. Sorry. 1.282
Mm-hmm.
equals, so we're trying to solve for x.
Yeah, so that would be times the standard deviation.
Yeah, so the mean is the 152, or sorry, not 152, 542.3 divided by 120.54. So you're going to times that other side by 120.54. Sorry, I'm doing this on
And
my
then
phone.
you add the mean, you add the mean.
Yes.
Mm-hmm.
So
1.282 times the
120.54, which equals 154.53228. And then you add the 542.3. Which equals 696.83228.
okay. So is that the 10 percentile?
Yeah, so the answer is find the GMAT score that corresponds to the 10th percentile. So it would be 698, or wait, 696 point, round to the nearest whole number. So it's 697.
It's a whole number, 697?
Yes, because it says
Okay.
round to the nearest whole number.
Okay, so 697.
Yep. Hopefully I got it right.
Yeah.
I don't think I did.
10%. I just feel like it's right in front of my nose and I don't see it. Maybe I'm just tired. Maybe we are just tired, all of us. Okay.
I don't think it's right.
Say that again?
I don't think it's right.
Okay. Let's move on and then come back to 25. Or is it building up? Oh, it's building up. Ugh. Because now we have to find the 90.
Well, we're on number 26.
So what do you have on number 25? 697?
Yeah.
Okay, let's do number 26. Oh.
I don't think it's right because that should be smaller than the.
Then the 90%.
Yeah.
The first quartile.
Click
Okay.
on the areas under the curve until the area left of the positive z-score are shaded blue, which I did that.
Mm-hmm.
Type desired area at the top of the graph. 0.1. And it keeps on highlighting it. I don't know what it's doing.
This should be the easy part.
Yeah, it should.
Did you get 0.9001 as the area?
What?
No, never mind.
Yeah, I did. When I highlight both of them.
Uh-huh. Okay, I think I am a little bit lost right now. For 26 and 20, for the first quartile for distribution, score. Those quartiles are really gonna give me a headache before the test.
120. Okay, so I think I got it.
You did?
I'm using the normal distribution calculator that he gave us, and I switched it to where it says, here, I'll share my screen.
Okay.
Let me find our Google. Okay.
Oh, the value of the area at the bottom?
Yeah, so I'm doing it value from an area. And for area, I put 0.1. For the mean, I put 542.3. And then for the standard deviation, I put 120.54. And then I put below, because we want it at the value at the 10th percentile. And I got 387.8.
And this is for number 26?
I think so.
Can you repeat that? 3?
So it'll be, we'll round it to 388.
388.
And then so all we should have to change is this to 0.9. And it would be 696 0.8, so it would be the 697.
If we do it for 27,
No, so
where are
25,
you?
I'm on number 25 is 388.
Mm-hmm.
Number 26 is 697.
Okay. And the first quartile of the distribution.
Wouldn't that be 0.25?
Yes.
So I got 461.033, so it'd be 461.
Oh, 61. So for 27, 461.
Hold on.
It makes sense because if you have the 10% 388, it makes sense that it's around that number. Are you redoing or are you checking your numbers?
No, because I wouldn't know how to check them.
Okay.
Find the third quartile of the distribution of GMAT, so it would be 0.75. And it'd be 623, so it'd be 624 because you would round it up.
Okay.
Consider a simple random sample of n equals 25 students. Take the GMAT. What is the mean of the distribution of sample mean scores for all such samples?
Okay, consider a simple random sample of n equals 15 students. What is the mean of the distribution of sample mean scores for all such?
Should be the same mean for the mean. The mean is
It's the same.
3, right?
5 what?
540.
542, because it's the same for the mean of the sample means.
Oh, yeah.
It's 5 what? I'm sorry, I'm tired and I have a terrible back pain. Not that you need to know that. 540 what?
542.3.
Do they want decimals or they want the nearest tenth? Oh, one decimal.
Yeah, just one.
So that would be 542.3.
Yeah.
Thank you, Sylvia.
But we need to round it to the nearest. Oh, yeah, I see
It says one decimal place.
Yeah.
Mm-hmm.
Sorry.
You're fine.
So what is the standard deviation of the distribution of sample mean scores for all such samples? So that would change.
Yeah, that changed.
So it'd be a standard deviation divided by the square root of n.
Mm-hmm.
Yeah.
So it'd be 120.54 divided by, hold on,
The
sorry.
square root of 10?
Square root of 15.
Oh, hold on a second.
31.123.
$31.123.
123, yes.
Okay.
What is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600? So we need to put...
We need to use the large formula for Z-score.
I think I can use... Hold on.
So
Which
that would be... Do you have it, Sylvia?
Well, I think it's 600 minus the minus the mean, which is 542.3, and divided by the standard deviation, which is 120.54.
Divided the square root of 15.
Yeah.
I got 0.032.
Let me do the math again. I didn't get the same. So let me try again.
What you got, Megan?
I got 0.032. I just plugged it into that applet that he gave us.
Oh, okay. Yeah, I forgot to do it.
Because the mean is 542. Well, but we have a new standard deviation.
Did you get 495?
No. So we have to use the standard deviation that we just got. The 31.123.
Okay.
I used the 120.54.
Yeah, that's what is. But Megan is saying that we need to use the new standard deviation, 31.123, right?
Yeah, because we're trying to find it for the n equals 15. So we need the standard deviation for the n equals 15. So I still put the mean as 542.3, but the standard deviation is 31.123.
Yes.
Are you sure that we need to use that standard deviation?
I'm pretty sure.
Okay.
Because we're trying to solve for the n equals 15.
So what did you get?
I got 0.032.
Okay, that's the 0.032? 1 to 3 decimals. Do we went to there to save it and then submit it?
I'll submit it.
Well, we all have to do it, right?
Right, but
How did we do?
And so, Megan, what you got for question 31?
Hold on. We actually didn't do too bad. I got number 31 right. It's 0.032. So before you guys submit yours, if you want to fix these ones, we got number 18 wrong.
18.
And number 14.
We got number 14 wrong.
And then that was it. We only missed 2.
So what, do we know the answers about for 14 and 16 or
No.
18?
No.
Okay, let's see. The arterial 16. What location is most temperature from one seal to another?
No, we missed 8.
18. Oh, sorry. My bad.
What percentage of the data lies between 4 hours and 8 hours? Do we want to try the 0.5?
Yeah, that's
Yeah.
what I do.
So, oh, I'm sorry. 17 is 8, right?
Yeah.
17 is 8, yes.
So 18 is,
I think we said 0.5 is what Sylvia said.
Sylvia, what did you say for 18?
50.
50%.
Yeah.
That was nice and clear. Thank you.
And for 14, it should be, well, we have to do all over again the sum.
Ah. Okay, the sum of all fears. But we want to get it right. If we get it right, then Megan can submit it again and get 100%. Or one
Right.
of us can. Okay, let's do the sum for that one. We do have a formula. And we can do the sum. Okay.
Okay, the mean is 38.075. That's what we calculated before.
Yes.
I'm just filling my answers back in, guys.
Yes. Go ahead.
Okay, that's what we got wrong.
14.
The mean.
The mean we got wrong? Really?
The mean.
We all got the
Yeah.
mean wrong?
No, I didn't.
No.
The only ones I missed are number 14 and number 18.
Well, I'm doing all over again, like the math to get the standard deviation,
Oh, I see.
and I just sum all the temperatures, and I got 37.925. Is that what you got, Perla?
No.
So what was the answer you got?
Let me see. Are we talking about 14, right? I'm sorry. I am a little bit tired. I woke up today at 4:45 and it's already.
Oh no, we got it. It's okay. It's 38.075.
Yeah. So what are we doing wrong?
Okay, that's the mean. Now I'm doing the next table.
Are you doing the x minus the mean?
Yeah.
Okay, let's do that.
So the deviation from the mean for the first is minus 0.165.
Yes, and the second one is minus 0.825.
What you got? Minus
Minus 0.825. The next one is 0.905. And the last one is 0.085. So do we add all of that?
Yeah. No, to do the next one, which is square deviations. And then we got the variance, and then we got the standard deviation. Am I okay?
So now we add the square deviation of those numbers, each individually, and then we add the sum.
Yeah.
I feel good going in the quiz that we got that many right, though.
I'm amazed that we got. I thought maybe we get 60%.
Right? I'm pretty happy with what we got, even if we don't.
I think between all of us, we will do okay on the test. We should take it together. I'm just kidding.
You guys really need to use that applet that he gave us.
Yeah, I need to get more familiar with that one. But honest, I'm really tired today.
Oh, I know.
My husband deployed on Saturday, so I got the full draft of seminary and stuff. I have 2 children in seminary.
Yeah.
I have a senior in high school and she's taking finals. So it's been a fun day.
I work in a high school, so.
How do you like it?
I like it.
What do you do?
I'm like a campus security guard.
Oh, okay. I like you. I like you. I like that. That is a great position.
The kids don't like me.
Oh, they're not supposed to like you.
I'm the younger one, so they talk to me more. So I find out a lot, which is kind of fun.
And at the same time, they have the right person there. You have wonderful, the right values. And yeah, right. I think you're doing a great. I have high respect for those who work in high school. Really, I really do. Oh yeah, believe me, I do. Okay, so did you get all the square roots?
Yeah, and I got the same answer. I don't know what I'm doing.
Wrong?
What do you have on 14?
14.
We all got it wrong, right?
What do you have?
1.239.
So did we round it wrong, maybe?
I think maybe we made a mistake there. Let me try to check it out.
So, Megan, are you checking if we have the same answer there?
Yeah, so when I submitted it, I answered it number 14 with 1.239.
I got 0.118.
You got 0.118?
Yeah.
That's what you got in Excel, right?
No, I am doing it by hand.
So what you just did, because I don't know, the variance is the sum of the square deviations, right?
Yes. Let me see, I have my graph right here. My little table.
So
okay. The
the
variance is 1 minus the probability. Oh, that's what I'm doing wrong. Oh. No, I really have no idea right now at this point. I am tired, I'm sorry. Okay, Megan, what is your advice?
Do we know what the answer to number 18 is?
We said 50% to number 18.
Okay, well, let's submit that and see if we get that right. And at least we'd get one more.
But you don't have any more chances.
I know, but I'm saying one of you submit it.
Okay. So let's see. What do we have in number 14 again?
1.239.
1 point what?
239.
239. 1.239. Let me submit that and hopefully.
Hey, and how long should be this lesson? Because it says 2 hours and we're almost.
Wow, did we take the same test? Because I have lots wrong.
Really?
Yeah. Okay, let me tell you what I got wrong. Let's see. Question number 2. I had 2 and 3. And it
And
says
I
I
did
have.
only 2.
You did what?
I only put number 2.
Oh, okay. So on question number 2, I should just do B.
Yes.
And then on number 13, oh, I got C and it's wrong. What do you have on number 13?
1 second. Number 13, I put the mean.
Okay.
The mean is correct.
1 second, I'm checking.
Yeah, because I got the variance and it's not correct.
Sorry, my thing's jumping around. Yeah, the mean is correct.
So the parking lots were not a number.
No.
The what?
The age of randomly selected vehicles, the age of the cars was
Yeah.
not. It
No.
was just the toothpaste.
Yes.
So that was number 13, and 13 is the mean.
Yes.
And I got 14 wrong.
We all got 14 wrong.
Yeah. And question 18 is 50%. You were right, Sylvia.
Phew.
Okay. That's it. I got 92.48.
So what should we do with that 14?
Submit yours. Yeah, I don't know. We need to work on this one and find the answer because we need to understand it. I mean, I know I do.
Yeah. Okay, so I'm going to submit it.
Oh, Sylvia, can you put the link on it, the thing, so Maple can see it? She said that she was gonna see it tomorrow.
I'll just send the link to Maple in the little group chat that we all use.
That works. Thank you.
Okay.
And thank you for your help tonight. You were awesome, both of you.
I feel like I actually might understand it.
You're doing pretty good. Now you just need to teach us how to do it.
Mm. Hey, I got the last one wrong.
Oh, just the last one?
No, and
So write down the answers that you need to correct. Go to the top and then go from there and we can check with you because I got.
okay, I got
So we all have
13 wrong.
13?
Yeah.
I think it's the same one that we all said that it was the variance. I think I said the variance and then Megan didn't listen or just put the mean and then she was right.
I put the mean and it's not correct.
I put the mean and it is correct.
Really?
Really?
Wow.
Yeah, I put the variance and it's not correct. So I'm guessing the mean is the one that is correct.
And what did you put on question 31?
31. 0.032.
That's what I got wrong.
Is that the only one? And
Well,
14, of course.
yeah, 14 and the one and that it says the mean or the variance.
Yeah, I put the variance. I know that Megan put the mean and she was right.
Let's
Okay,
just
say that again.
hold on. I'm just rechecking all mine.
Okay. Are you gonna submit it again, or are you gonna just?
Yeah, I'm submitting.
Okay. Do you wanna check your answers with me, or
Oh no,
or
I
can
was
you see both?
checking them against my own,
Okay.
and then against what. So yeah, for 13, you're right. I did get it wrong.
So it's not the mean
No.
and it's not
Okay.
the variance. So
It's not the mean. It's not the variance. Let's make sure that Maple knows that. Did you stop the recording?
No, I haven't.
Stop. If you want, you can stop it, and then we can tell Maple that on an email or our chat.
Well, if we
What
record it, we'll have
quantity?
the right answers.
There you go. What quantity is equal to the sum of the numbers if in the square deviation column?
Is it the standard deviation?
The square deviation. No, because you then you put the square deviation. Is it none of this is correct?
I'll try it. I don't care. I already missed
I
all these.
like you. You're daring. I can see you, like, let's jump from this plane. I go first.
All right, I'm number 15. Hold on, let
It's
me
a
make sure these are all right.
It's a compliment, Megan. I think you're
Oh,
awesome. I think you're really brave.
okay.
And I'm losing my voice.
Eight, 50. Sorry, it takes really long to scroll these. Six. Last three.
Watch out with the numbers. You need to be careful with those. Maybe Maple can find the answer for 18.
So I got 96.7%. So
Nice.
did you miss, Sylvia?
I'm doing it again.
Okay.
So did you get 13?
I think so. Yes, so it's none of these is correct. 14, I didn't get it.
Okay. And we didn't get 13, right? Are we done?
I'm done.
Sylvia, did you take it?
Well, I'm doing it now, but if you need to leave, I can do it alone.
No, do you need help? Do you have the other right there?
Yeah, I have the other. I only 14, which is the gray mystery here.
Maybe Maple is gonna find the answer to number 18 and she can tell us what she did, right?
Maybe. I hope.
Yeah, 14. So we were right when we did the math for number 19, guys. We need to be careful when we take the test because all of that, and we just added the two of them and then we divided by 2. That's all that we did on number 19. Megan, did you stop the recording?
No, not yet.
Okay, are we waiting for Sylvia? Sylvia, we're waiting for you.
Okay.
Oh, whose baby is that?
It's my baby.
How old is your baby?
Yeah, she's sleeping.
3 years old?
No, she's 8 months old.
Oh, you have a 3-year-old and an 8-month baby.
No, just one.
Oh, you have one. 8 months old?
Yeah.
Oh, so new.
And she's tired.
I know how she feels. Okay, ladies, I think I'm gonna go to bed. It's 11. Almost
Okay.
11:15.
Yeah.
Okay, thank you for everything, Megan and Sylvia. I really appreciate all your help.
No
Thank
problem.
you.
Have a good night.
You
Thank
too.
you. Bye.
Bye. Ya, mi amor. No, niña.
I think I'm gonna go too, Sylvia.
It's okay. I'm
Sorry.
no, it's okay. I'm going slow because just doing in one hand.
Yeah.
But
Well,
thank
good luck.
you.
Yeah. Bye.
Bye.